Greetings everyone. I am Bona Sekagarama, an applied statistician specializing in data analytics and research design. I'm here to help you master data analytics using Python. If you encounter any challenges or have any questions regarding this course, please don't hesitate to reach out. I am here to support you on every step of the way. Let us embark on this exciting journey of knowledge and exploration together. Thank you.
Session 7, Creation of Pivot Tables. In our earlier sessions, we discussed on various types of tables specifically designed for categorical variables. In Session 7, we will advance our skills by learning how to create pivot tables. What is a pivot table? The term pivot table itself comes from the concept of pivoting or rotating the data to view it from different perspectives. It refers to the ability to rearrange data dynamically to view different summaries or aspects. It's a tool for transforming and analyzing data efficiently. Example, imagine you have a list of sales and consumption data with the following variables: date, product as a categorical variable, sales amount, consumption, etc. as quantitative variables, region as a categorical variable. Now, the combination of categorical variable or categorical variables and a quantitative variable yields the statistics such as mean or average, median, standard deviation, sum, etc. So we open the Python Jupyter notebook in which we are going to import our data. Here, you make sure that it is installed in your laptop. Okay. Go to desktop and then search for your folder, Session 7. In this folder, that's where your data from is located. Go to New, Python 3 to open your command window. Okay, this is our command window. You can see here untitled. Let us title our command window, and we call it, for instance, Session 7. Session 7. Pivot tables. Name. The title is Creation of Pivot Tables. Okay. We import our pandas library. Import pandas as pd. Run. Then we are going to import our data frame. We call it any name. For instance, auto, and then you bring your pandas library pd.read Excel within inverted commas. Go to your folder and go to desktop and then open Section 7 folder. This is my data frame, dataset. Go to Properties, and then copy the location. This is your location. Load it here. So this is the folder, our folder, Section 7. Then, this is our location, the whole of this. So go back to bring the data frame. It is named the dataset. Copy it. Dot extension of Excel is XLSX. XLSX. Then run. No. Double backslashes. Run. Then execute your data frame. Run. So this is our data frame. Has got 66,081 rows. There are also 66 columns or variables. So let us limit our data frame to 1 row. Okay. This is okay. This is fine because as we compute statistics, we can easily see our variables here. Okay. Now we are going to create the table for expenditures or average expenditures by region. We have the variable region and expenditures. Expenditure by region. Okay. Now bring your pandas library dot pivot table. Data equal your data frame. We called it auto. Then index equal being your categorical variable, which is region. Then values equal being your quantitative variable. Our quantitative variable is expenditures. Copy expenditures. Then we run. To run, you can either click this, you select your command, click run, or select your command and then press shift and enter. So this is our pivot table. This is average expenditure by region. Okay. Here, if you want some statistics like average, standard deviation, and sum to appear on this table, you can add another argument, which is aggregate consumption, aggregate function, func equal to pd, np is in numpy dot to mean, then run. So you can see name np is not defined, numpy is not defined, meaning that to create this table with the mean to appear on the table, mean, standard deviation, sum, variance, and so on, you should import the library named numpy. Okay, go back and import numpy. Import as np. Run, go back to command. So you can see how the table looks like now. Okay, mean expenditure, or you can say average expenditure. Average. Run. Average expenditures by region. You can add also standard deviation. Average or mean goes with the standard deviation. NumPy dot standard deviation. And average expenditures by region. Standard deviation by region. Okay. We can also add summation of expenditures by region. NumPy dot sum, and then run. Running is shift enter, the shortcut. You can see the average expenditure by region, standard deviation of expenditures by region, and then total expenditures, the overall expenditure, sum of expenditures by region. Here, for instance, in the city of Buiza, this is 3.882174 E, this is E times 10 power 9. For in Eastern region, this is 4.15, 10 times 10 power 9. Meaning that here in the city of Buiza, this is 3 billion, 3.9 billion. Eastern region spend 4.2 billion. Okay. Then the region that spends less is the northern region, which is 2.6 billion. There is another thing lacking here on this table, the total. The total here, total average, total standard deviation, and sum. Here, after aggregate function equal to this, we add the total. Total. Let us continue the command from here. to add the total, column total here. This is margins equal true, then margins equal total, then run. You can see how the table keeps on changing. This is our total average expenditure, total standard deviation. This is the summation of expenditures country, which is 19.5 billion. And okay, 19.5 billion. How do you verify this figure? If it is 19.5 billion, you can use this command here. Link your data frame, then expenditures dot sum, and then run. You can see this is 19 billion for 19 billion 48 million. No, this is 19 billion 4 million and 88 844,000 and 367,100.6. So, which means this is 19.5 billion. Okay. It was just proving how to read this figure. Okay. We can copy the same command down here. We will replace the categorical variable region by another categorical variable urban rural. The name of urban rural here in the data frame is type of place of residence. Copy it and replace it here by region. Then we run. So these are two different tables. This is expenditure, average expenditure, standard deviation, sum expenditure by region, and this is expenditure by rural and urban. Okay, this is 2x2 table. One categorical variable and one quantitative variable. You can also change this table to 3x3. Index here, index is only one categorical variable. You can add another categorical variable as index. Let's say gender. Here we have two categorical variables as index and one quantitative variable, which is expenditure. Run. You can see how the table looks like. 3x3 table. It has got three variables. two categorical variables, which is type of place of residence, gender, and a quantitative and one quantitative variable, expenditures. All three variables combined in one table. Here, in rural areas, the average expenditure males spend more than females. In urban areas, the average expenditure for males is also more than females. So the expenditures always for males, always males spend more than females. Overall, some expenditures. In rural areas, females spend 6.3 billion. And then males spend 5.9 billion. In urban areas, it is the same. This is 3.64 billion, 3.60 billion for males. So in terms of sum, the overall expenditures in both rural and urban areas, females spend more than males. In terms of average, because this is individual case, spend more than females. Okay. We can also change the appearance of this table where two categorical variables here, gender and the type of place of residence, are indices. Okay? We can make only one categorical variable, the index, and another categorical variable as a column. Let us copy the same command here, down. First, okay, gender. We omit gender here. Only one categorical variable is the index, type of place of residence. And then after values, we also include the columns. Columns equal. So this is another categorical variable, gender. Gender is going to be indicated as a column here, column. And then type of place of residence as index. Our command, let us make it like this. Okay. Then run. If you run, you can see how the table changed. Type of place of residence, which is urban rural, is now indexed. And then gender is represented as column, as females, males, females, females, males. So in the columns. This is a different table. If you can see it, it is different from the preceding table here. Why? Here, the two categorical variables were indicated as index. But here, one categorical variable down here, one categorical variable is the index, another categorical variable is the column. So the rest is the same here. This is how we create pivot tables. Thank you for watching. You can now subscribe, like, and comment, and then we'll meet for the next session. Thank you.